topics. So this is about introduction to decision structure, or what's called selection. So we use the if statement or the if-else statement. Comparing strings means something is the same, something is greater than the other. Nested decisions, if you have a decision inside another decision. Logical operators, and then boolean operators. I think we mentioned this, like true, false statements, and so forth. All right. So what is a decision structure? It's a selection structure, allows a programmer to perform actions only under a certain condition. So different types of decision structures include if, also called a single alternative. For example, if you say, if it rains tomorrow, then take your umbrella with you. That would be a single without giving another option, right? Then we have if, then else, also called a dual alternative. So you can have if it rains tomorrow, take your umbrella with you, or if you decide, just stay home, or whatever else that you want to say. Then we also have what's called a case structure for multiple alternatives. Basically, you define it once in the beginning, and then you give the choices. So, for example, you would say in the case of the switch, you will say something like, let's say Tuesday, and then you start with you say Tuesday. So the choice is Tuesday. So you say if it's Monday, go to school. If it's Tuesday, that's the day you get to stay home. If it's Wednesday, you have a class. If it's Thursday, you're going to the gym. If it's Friday, so you give everything else, but you make the default to be the Tuesday. Does that make sense? So the if statement is a control structure, logical design that controls order in which a set of statements execute. So a sequence structure is a set of statements that execute in the order that they appear. A decision structure is specific actions performed only if a condition exists. If it rains, right? Only if that condition happens, then you will say, then take an umbrella, whatever else you want to say. So it's also known as a selection structure. That's just another name if you hear both. Okay. In a flowchart, similar to the Raptor that we use, is a diamond represents a true-false condition that must be tested. So actions can be conditionally executed, performed only when a condition is true. Otherwise, it will take the alternative. If it didn't rain tomorrow, then you will go what? With the other option, right? Single alternative decision structure provides only one alternative path of the execution. If condition is not true, it exits the structure. So it kind of looks like that. So there's an action only occurs if the decision is true. So if condition, then statement, then end if. A diamond symbol is used in a flowchart. So here you have cold outside. If it's true, you wear a coat. If it's not true, it just exits. Okay. The syntax for the Python is if condition, and then you have colon, and then whatever the statement is. First line is known as if the if clause includes the keyword if followed by a condition. The condition can be true or false. When the if statement executes, the condition is tested, and if it's true, then the block statements are executed. Otherwise, the block statements are skipped. The Boolean expression is expression tested if the statement to determine if it's true or false. So example, if A is greater than B, then that means it's true. If greater than B, then false otherwise. So you have relational operators, determines whether a specific relationship exists between two values. Example, greater than. I'll show you an example of that, which you will need to do also in your, I don't know if it's the next lab, which is basically you're asking if the money is enough, right? So you have to check it. So for example, the last example we seen one of the students I was playing, it showed that it was what, $78 something? Imagine if a customer gives you $50. Is that money enough? Are you going to say, oh, the change is minus 20 or whatever? No, you're supposed to say, no, this is not enough, give me more money, okay? So the greater than or equal to or less than or equal to operators test more than one relationship. It's enough for one of the relationships to exist for the expression to be true. Okay, the equal to operator determines whether the two operands are equal to one another. So do not confuse with assignment operator. Is not equal to operator determines whether the two operands are not equal. So these are some Boolean expressions using relational operators. X is greater than y, x is less than y, x greater than or equal to, and so forth. Okay, so using Boolean expression with the greater relational operator, you have sales greater than or equal to 50,000. If it's true, then you give a bonus. Otherwise, you exit. Okay. Any relational operator can be used in a decision block. So example, if balance is equal to 0, or if payment is not equal to balance. And it's possible to have a block inside another block. Okay, so if statement inside another function statement in a block must be indented with respect to the outer block. Remember, Python uses indentation to separate rather than using braces as a block in other languages. The if-else statement is a dual alternative decision structure, two possible paths for execution. One is taken if the condition is true, and the other if the condition is false. So the syntax would be if condition, the colon, statement, then else, and then the other statements. If clause and else clause must be aligned, statements must be consistently indented. So if then else statement executes one group of statements if its Boolean expression is true, or another group if its Boolean expression is false. So here you have if temperature is less than 40, then false. If it's true, if this statement is true, then you say a little cold outside, and then it exits the block. Okay. So some examples of conditional execution. Basically, the structure you have if the condition, if condition, else statement, however you want to put it out. You can compare strings. Can be compared using the equal to sign or the not equal to operators. So string comparisons are case sensitive. So a string can be compared using the greater than, the less than, the greater than or equal to, the less than or equal to. Compare characters by character based on the ASCII values for each character. We discussed this. If it's capital A for the ASCII values, it would be what? We discussed this in chapter 1, I believe. No? The number. What would be A? What would be B? What would be C?
A would be like 90 and above.
No, that would be if it's small case. If it was small a, it would be 97. But how about if it was capital A? 65. We went over this in chapter 1, right? So based on values for each character. So that's what it compares. It gives you the number. So in shorter word is a substring of longer word. Longer words is greater than the shorter word, and so forth. So here it gives you an example. So Mary, for example, M is 77 because it's capital, and then small a becomes 97. Small r is 114, and so forth. Then Mark, it will compare. Yes, the first two values are the same. Yes, the third one is also the same. Now Y here is 121, but K is 107. Okay, so that means Mary is greater than Mark. Okay. So nested decision structures. So decisions are nested in order to test more than one condition. If then else example. For example, if the salary was greater than or equal to 30,000, then you're checking if this user would get a loan or not. If years on the job is 2, then it's true, then you qualify for the loan. So if it becomes true in the first case, but then again, it fails that they have not been on the job for 2 years or more, then it would be you must have been on the current job and so forth, then you would exit. If it fails in the first time, then it would exit that structure. Okay. It's important to use proper indentation in a nested decision structure, so important for Python interpreter. Makes code more readable for a programmer, and rules for writing nested if statements. Else clause should align with matching if clause statement in each block must be consistently indented. So the if-else statement, a special version of the decision structure, makes a logic nested decision structure simpler to write, and here you have an example. So you have if statement, the if condition statement, then else if condition statements, then and then the last one would be the else. Okay. So you can align using with if else statement. If you can write elif or else if clauses are aligned, conditionally executed blocks are consistently indented. Again, this is only for Python. The other language just actually use else if, but you can still use it here as well. So if else or if elif else statement is never required, but the logic easier to follow. So it can be accomplished by nested if else. And code can become more complex, and indentation can cause problematic long lines. So here you have an example. If the score is greater than or equal to, if that's true, then you get an A. If it's false, then you see, okay, is this greater than or equal to 80? If it's yes, then it's a B. Now, if it's not, how about C, and so forth, okay? And then that was the logical, the flowchart. This is an example of the Python language. You can say if score is less than 60, then display that. Else, if score is less than 70, then display that, and so forth. Then you have the case structure. Basically, you define what month, and then to be the default, and then each month you give it whatever you want to do. So the case structure lets you value a variable or an expression, determine which path of the execution the program should take. So you can use it as alternative nested decision. The logical operators are operators that can be used to create a complex Boolean expression, and an OR operator, binary operators to connect two Boolean expressions into a compound Boolean expression. The NOT operator is a unary operator which reverses the truth of a Boolean. So for the AND is when two statements are true together, OR is as long as one of them is true. And then the NOT, it negates basically. Okay. So the AND takes two Boolean expressions as an operand and creates a compound Boolean expression that is true when both sub-expressions are true. For example, if you say that you have to be a resident in, okay, so let's say you have a form that you're filling out, and this form says that you have to be a resident of this county, and you have to be a computer science major for you to get the scholarship. Okay. Now you're filling out the form, and it says, "Are you a resident of the county?" If you say yes, then it will take you to the next question: Are you majoring in computer science? If you say no, then it becomes false, because remember that the AND, it takes both operators. It has to be true and true to give you true. Now, if you ask the question, "Are you a resident of the county?" and you say yes, "Are you majoring in computer science?" and you say no, right? One of them fails, then it will be false. So if you have a true and a false, it becomes false. But if you say you are a resident and you're majoring in computer science, that means both of them became true, then you will get the scholarship, it becomes true. Does that make sense? Yeah, so I'm still explaining that, right? So how about if you say false in the first one, you're not residents of the county, but you're majoring in computer science. So that would be false and a true, but it will be false. And if both of them are false, then you don't get the scholarship, okay? The OR is different. The OR just looks for as long as one of them is true, okay? As long as one of them is true. So creates a compound Boolean expression that is true when either of the sub-expression is true. So again, we look at the truth table. So you have, if it's false and a false, it's a false. It's not like math that two negatives give you positive. It's not there. If it's a false and a true, it's true. Again, all it's looking for is one truth. True and a false will be true, and a true and true would be a truth. You are a resident of the county? No. But you're majoring in computer science? Yes, you get the scholarship. Does that make sense? You're a resident of the county? Yes. But you're not majoring in computer science. You're majoring in history or something. Would you get the scholarship? Yes, because it's only looking for one of them to be true. Okay. We have what's called short circuit evaluation. The short circuit, like it says, when people say this person is has a short circuit, do they say that? Or when they say there's a statement they use, I'm trying to remember.
Short views?
No, it's an expression that's used. So let's say a person that gets ticked easily.
Yeah, short views.
Short views, okay. So it's like you better get it right the first time. So the short circuit evaluation here is similar. So for example, you need two statements to be true, right? Like in the case of the AND statement, okay? You want both of them to be AND, right? Like you are residents in the county and you're majoring in computer science, correct? Now, the first thing you say is, "Are you resident of the county?" And then the person says, "No." You'll be like, "Bye." Like, "No, wait, I'm actually majoring in computer science." No, I don't want to hear that. Because the AND is what? Both of them must be true. You'll be like, "No, I don't want to hear it. I got the first one, you said no, because I need two of them to be true. But let me finish my statement, no." That's what the short circuit is. I'm going to say no anyways. Does that make sense? So that's the short circuit. But if one of them becomes true, so in the case of the AND, it's still talking about, right? Now, if, are you a resident of the county? Yes. And now you wait for the answer for the second one. If the answer is yes, then they'll get the scholarship. If the answer is no, then you go on to say no, you don't get the scholarship. For the or, it checks one of them to be true. So let's say, are you a resident of the county? Yes, okay, here's the scholarship. Like, wait, I didn't even give you an answer. No, I just needed to be one of them to be right. Does that make sense? Because you only need one. But if one of them fails, let's say, are you a resident of the county? No, then it will go to the next one. So for the short circuit, for the or, it just needs one to be right. And if the first one happened to be right, then that's it. The person gets it. But for the and, it needs two of them to be right. If the first one happens to fail and you say no, then you'll be like, bye. You only go to the next one if the first one becomes true for the and.
So you need for the or, you need one of them to be right in order for it to be true, and then for the and, you need both of them to be right to be true.
Right. But in the case, I'm explaining the case of the short circuit. For the and, if you fail at one, it will exit. You say bye. But for the or, it just needs one to be right, and it will say, okay, here it is, like without even getting to the next one. Okay. The not operator negates everything. Basically, you say yes, I say no. You say no, I say yes. Basically, a negation to everything. You say cold, it's hot. That makes sense? It's just a negation. So and sometimes it's necessary to place parentheses around when you're setting up, okay, statements. So checking numeric ranges with a logic operator. So to determine whether a numeric value is within a specific range of values, use the and. So example, you can say x greater than or equal to 10 and x is less than or equal to 20. This again similar to if you are using absolute values of less than or equal to when you set it up as a compound. To determine whether a numeric value is outside of a specific range, you use the value or. Okay, so x is less than 10 or x greater than 20. You have Boolean variables. Boolean variables reference one of two values, true or false, and you can use the data type bool data type. So a flag variable that assigns, so commonly used as flags, so it's variable that signals when some condition exists in our program. So you can set a flag set to a false, condition doesn't exist. If it's set to true, condition does exist. And how you can declare it. Here you have variable of the Boolean data type can be one or two variables. So here you have declare Boolean is lunchtime, and then if time is greater than or equal to all of them, set lunchtime is true. Else set lunchtime is false, and then end if state. Now let's look at some examples on how to do this. So in a Raptor, the symbol that is used for decision of a structure is this. It's called selection. This right here, selection. This is loop. We'll get to it maybe next class. So this is a selection. But before we can drag this in here. Right? It's asking me to save. We can say loop test or something like that. I'm going to save it in the desktop. All right. So let's say in the case that you guys had in the last project, and you were asking something about money, right? So let's say customer gives you some money. So we can declare that right in the diamond. So here we can say total or something like that, okay? And then we want the total to be greater than okay, if you want to say 90, all right? And then if it's greater than 90, then we want to say some type of message, right? We want to put some output if it's greater than 90. So here we can say, thank you, something like that. You have given me enough money. Whatever, right? Some message that shows that they have given you enough money. And then you can put an output here if the money is not enough. Money is not enough. Give me more. Something like that. I'm just showing you the decision if something doesn't become true. But then again, how do you decide this, right? So we ask the user, right? we're asking them for them to give us the money. So we can get an input here or something like that, and then say, give me money. And you can store that here, variable called total. We are using total here. If you're using total here, I'm going to use total here, something like that. Okay. Now let's run the program, and then it says, give me money. Right? Like, there was a guy that walked in. I was at the what do they call that? Not Popeyes. Papa John's, was it? Actually, it was Popeyes on Annapolis Road. And then a guy just walked in. He said, "Drop the chicken." Everybody was scared, but then again, everybody started laughing. Right? Kind of like, give me the money. So here, let's say the person puts in $80. Okay. So it says money is not enough. You see that? So how about if they put in, let's say, 91? That's the other route. Thank you, you have given me enough money. You see that? So if it's true, it would go here. If it's false, it would go the other way. So in your project, as you're working on, you will be adding some type of selection like that when people make a choice. If the money is enough, it's not enough. If it's enough or if it's not enough. Yeah. Does that make sense? So I see. And again, I just took the shortcut here, but again, you could be, before you actually ask for the money, you may have something that displays how much they actually owe, like that user, because you already calculated all that, you have it done. You just enter something like this, copy it and paste it to that code, and then whatever the output was, that's what you're asking for. Okay. Here, I said total is greater than 90. In your case, it will be total greater than or equal to whatever that your total was. Equal, greater than or equal to. So here you can set it as total greater than or equal to, but instead of 90 in your case, it would be like cash tendered or something like that. You create a variable here, because in your case, because they're giving, you already calculated this for them. Or you can say here, it can be the cash tendered or something like that, and then here it would be the total, like whatever, however you calculate it. Does that make sense?
Yeah.
Okay. So this is basically, you use this one to decide or to write a selection or a decision statement. All right. In Python, again, the same thing. You would define it. Let's say somebody orders, or let's say if they order chicken, and that's a true statement. Or if they order banana, and that becomes true. Like, and then we ask the user, let's give it a choice. So we will say choice equals, since we have 1 and 2, this will be an integer, and then I'll say input. Okay, let me make it bigger so you can see. I'll say input. What do you want? Chicken or banana? Yes. Thank you. What do you want, chicken or banana, right? Now, we write the if statement. If, let's say, choice equals 1, we would say print, you have ordered chicken. Enjoy the meat. And we can say else if choice equals to print you have ordered banana, the fruit. And you can say else do something already, or something like that. Okay. So we run it. Where did I make a mistake? This is line 3. Choice. I didn't end the quotation here. And then we run it. So what do you want? Chicken or banana? So I can put in, 1 was what? Chicken, right? So if I put a 1 in, it will say you have ordered chicken. Enjoy the meat. But if I put choice 2 in, okay, you have ordered banana. Enjoy the fruit. How about if I don't put in either 1 or 2 and I just put maybe something like a 0? Do something already. Like it will give you the default, the last one. Okay. So you're basically giving a choice of to take what route to take. Is it the first route? Is it the second route? And so forth. Okay. So these are some examples of using decisions, if-else statement. And this is what you will be doing as you get to project 3 or 4. Again, I'm just showing you the Python, but you will be using it once you get to project 4, I believe. I think it's, or is it 5? 5, 6, 7, I think. But the first 3 of 2, 3, and 4, you're just using the Raptor. All right. Any question on the 2 examples? So this is a decision. All right. Again, go back to this video over and over again just to give you an idea, and make sure you comment and document your code. All right.